Please welcome Alberto to the stage.
Thank you. All right. Thanks. Oh, this is pretty cool. Thanks, guys, for being here and for going to my talk. So all right, there you go. So my name is Alberto, and I'll be presenting you on behalf of Moonbeam how we connected Moonbeam and Moonriver trustlessly, right? And this is all nothing that we developed as a company. This is all using like parity developed technology that is available to everyone that want to use it in the ecosystem. So first, let's state the problem, right? So Moonriver, it's a parachain in the Kusama ecosystem. It had a bridge. It was a third-party bridge called Multichain. It was formerly known as AnySwap. And as you may know, it was not a hack. People called it a hack, but it was basically a design problem in which people thought that multi-chain was somewhat decentralized, but everything was running under a single person. This person was a Chinese citizen. He was arrested by the Chinese government, and basically the bridge went with him, right? And it was widely covered in the news. There were around $130 million of funds that were affected across two main chains, mainly Phantom, and in second place, Moonriver. This was widely covered in news. This one is by Chain Analysis. I left the URL there if you want to check it out. It was also covered by CoinDesk. Once again, $130 million basically were hacked, even though some of them say hacked, but it's actually more like an exploit. And I don't think it was an exploit. I think it was just basically a flaw in design because you were trusting in a centralized party, like the guy who was running the bridge himself. And this other one was by Blockwords. So what I'm trying to say here is it was a pretty public known exploit that happened, some time ago already. And so after this happened, Moonriver became isolated because even though Moonriver is connected with XEM, it is not really, like the Kusama ecosystem was not as lively as Polkadot, right? And so as Kusama parachains stopped producing blocks, Moonbeam became very isolated to the world. Like, it was basically by itself. And so the only two assets that were being moved were basically KSM and Moonriver. And that was basically it. And so one of the solutions could have been to use what is called the Polkadot Kusama bridge to connect Moonriver to the outer world. And I try to make it as simple as possible, but you can see that it's like many hops, and that doesn't really provide a great user experience and also developer experience, which is also very important because when you're maintaining a stack that relies on so many moving parts, it's really hard to make up with a great user experience, and it can break, and you don't even know that it's going to break because for example, if Asset Hub or Bridge Hub are updated and you were not part of the process or whatever, something can break in your flow of trying to move funds from Moonriver to Moonbeam or to every other place in the Polkadot ecosystem, right? So in this flow, you had multiple hubs because you needed to go through Asset Hub, through Bridge Hub, and then Polkadot Bridge Hub, Polkadot Asset Hub. And even though this should happen seamlessly without you needing to do much, there were a lot of dependencies there. And so we thought this was a really complex system to something that could have been solved or was solved a lot simpler, in a much simpler way. Another solution could have been just use external bridges, right? Like these are bridges that are very well known in the Web3 ecosystem. You have Wormhole Layer, Zero, Hyperlane, Connects, Axelar. They're players that are around. They have different properties, different designs, different architectures. They have pros and cons. But one of the common patterns that we started seeing was that the integrations were costly, right? They don't do it for free regularly. They take a lot of time. Like, okay, if you say, okay, yeah, we're ready to move forward. All right, guys, we'll be ready in a year, right? And that doesn't really work well with an ecosystem that wants to be connected. And some of them have different design models. Some of them have more centralization risks, right? And so it was really difficult for us to work with an external bridge. When I was prepping this presentation, I thought, what about Hyperbridge, right? And there would be a question in the audience saying, hey, why do you guys use Hyperbridge? And when we started making these decisions, Hyperbridge was not as advanced as it was now, and so probably in retrospect, we could have used Hyperbridge, but these are decisions that you make months in advance, and you work on them and so on. And so at the end of the day, hopefully I answered a question ahead of time. I don't know. So yeah, at the end of the day, we went with a direct Moonbeam to Moonriver bridge. It's direct. There is no middleman. Well, there is an infrastructure component in the middle, but there's no hubs between, bridge hub, asset hub, and anything. And the way that this works, we're going to start with a very simple concept, and we're going to dive a little bit deeper every time to try to, we're not going to go to every single line of code, but the idea is to start simple and then start moving into more parts of the tech stack, right? So at a very, very high level, the way that this works is that you have Moonbeam, which relies on consensus and the source of truth that's given by Polkadot, and then you have Moonriver, which relies on Kusama, okay? The main problem that we're trying to solve is that there are two different consensus algorithms, right? Within the Polkadot ecosystem, it's really easy to do cross-chain because all the ecosystems in the Polkadot ecosystem are already trusting on Polkadot. So you don't have a trust problem there. You already trust Polkadot for finality. But the problem is that when you're trying to connect two different consensus algorithms, right? And that's what we see with Snowbridge between Polkadot and Kusama and Ethereum and any other bridge out there. And so the easiest way to explain how the Moonriver-Moonbeam bridge works is that you have Polkadot ecosystem, Kusama ecosystem, and then you have a component that is a relayer. It's an entity, an infrastructure component that just moves messages or moves information between Kusama and Moonriver. They inject that into Moonbeam, or Polkadot and Moonbeam, and they inject information into Moonriver, okay? That's the simplest way to understand it. The only attack vector here that could happen is censorship, right? Because if the relayer says, I don't like Torsten, I'm not going to move Torsten's message, right? But Torsten could just spin up its own relayer and then just move the message himself, right? And so at the end of the day, the only problem could be censorship, but because it's a trustless system, I mean, I'm not saying that every user should run their own relayer, but there is a solution to that problem that it's easy. It's not a complex problem that you want to solve. And so the idea here is that if you want to send a message, let's move an asset from Moonbeam to Moonriver, the relayer picks it up, and then there, let's say, finality justifications, grandpa justifications that are injected in a way by the relayer into Moonriver. The message is also passed, and then the message is executed on Moonriver, and then you have an asset or a message or whatever. So let's go one level deeper, okay? And it's in the corner here, but this is the source of this diagram. This was not done by me. This is done by actually Parity developers that worked on this. And one level deeper into the problem, this is how it works at a very high level, right? So let's say you want to initialize the palette or the modules that allow you to move this message trustlessly. So what you have to do is that at some point in time, at some cutoff point, you're going to say, okay, I have the block, finalized block 480 on the Kusama relay chain that has information about Kusama, but it also has information about Moonriver. And I have 42 authorities or 42 people that are signing these proofs on the Kusama relay chain. So I read the initialization data. I remember when we run this, it could take like 45 minutes to read all the information that it needs from Kusama. And then you inject that in the target chain, which in this case is Moonbeam. And you inject it in a series of pallets that will hold this information for you. And when you do that, now Moonbeam can verify this information that Kusama has. Kusama has its own information, but also information about Moonriver. And so now, let's say in a future, so this is like, this is the source target chain, but this is like time moving downwards. So in a future block, you can say, okay, now I am going to import block 503. I'm going to read the information, finality proofs from block 495, because that's the one that I have as a checkpoint. And so I'm going to submit that finality proof on Moonbeam, and now I can check the information that happened at block 495, okay? And so at the end of the day, it doesn't really matter if you missed any blocks because you can just find the next block that you want to import, and then you can just basically, with the proofs of the systems that you're injecting on Moonbeam, this can be verified by Moonbeam, and then you have a message that can be verified on the destination chain. But let's go one more level of complexity. It's not great how it looks, but I'll work through it. And so these are actually all the components that you need, or the pallets or modules that you need on each of the chains for this system to work, okay? And let's move through it. And so how this works is that once again, you have, sorry about that. You have the relayer here at the middle, and the relayer is doing multiple things, right? It's submitting grandpa finality proofs from the Polkadot relay chain on Moonriver, is listening to things that are happening on Moonbeam as well. For example, there's an XCM message that you need to move, and it's moving it to Moonriver. It's submitting parachain headers from Moonbeam to Moonriver, so it's doing a lot of things, okay? But at the end of the day, what matters is that this system, what allows you is Moonriver to verify that something happened on Moonbeam, and it can act on top of it, right? And once again, at the end of the day, what this is doing is that Moonriver is now trusting Polkadot, the Polkadot relay chain for consensus, right? And Moonbeam is now trusting Kusama for consensus. Because this is not, Moonriver said, I submitted a message. No, it's saying Kusama verified that something happened on Moonriver. And what happened on Moonriver? There was a message, an XCM message that it wanted to transmit to Moonbeam, okay? So there's a lot of moving parts, but when you start making sense of the diagram, what's happening is that, okay? There's a message queue that is happening on Moonbeam that then basically adds incoming XCM messages, and then Moonbeam, if it has all the information that it needs to verify that that message actually happened on Moonriver, it's going to execute it, and it's going to result in the action being done on the Moonbeam chain. So yeah, it's not that complex to understand if you understand the finality proofs on each of the relay chains and so on. And this is very similar to how Beefy works. And actually, the introduction of the talk had Beefy in it, but it's not Beefy, it's actually Grandpa. And the main reason about Beefy is that verifying this information on Ethereum is very costly. It's very, very cost intense. And Beefy is a way to sort of like, I don't want to say simplify the verification of signatures on Ethereum. Right? So instead of verifying everyone that you had on Polkadot, all the 700 validators or whatever, you only verify a subset of it. But in this case, you don't have to do it because everything here works under the same signature mechanism, Polkadot SDK, so it works very natively and very efficiently. So this actually makes a more robust system than, for example, Snowbridge in theory, because you're verifying every single one of them. So yeah, this is just basically a slimmer version of the diagram in which what I mentioned before, you're injecting relay chain finalized headers on authority lists on each of the chains, and basically Moonbeam verifies all the signatures, the finality proofs of Kusama, and then Moonriver verifies everything that is happening on Polkadot. And then there are also verifications that are happening parachain to parachain. So it's not only relay chain, it's also the storage proofs of the parachains that are being connected with the Trustless bridge. So when you now, these are multi-locations, which are ways to express things in the Polkadot ecosystem. So you can express anything. You can express an account. You can express an asset. And this is, excuse me, this is very common, a common way to represent assets on the Polkadot and Kusama ecosystem. And the main change that now happens is that the asset has now parents too, which means that you're going one level outside of the consensus that you're working on. So you're saying, I'm not going to the Polkadot consensus, I'm going outside of the Polkadot consensus. And here, sorry about that, here you're saying, okay, what consensus are you targeting from Moonbeam? You're saying, I'm targeting the Kusama consensus ecosystem, or however you want to call it. And then here I'm saying, in the Kusama ecosystem, I'm targeting Parachain 2023, which is Moonriver. And then I'm targeting the asset mover, or the mover token, okay? And so it makes it very natively, like this is how Polkadot or Polkadot SDK chains handle assets. And this for people that are working in the ecosystem, this is not like, this is the language they speak. So it makes it very easy to work with when you're registering assets and you're moving assets around from one place to another. And yeah, I want to show you a demo so that, at the end of the day, we made a decision on how we wanted to build the bridge. And we actually it's already live on the Moonbeam DApp, and you're gonna see like a short demo. I'm gonna talk through it, so you see how easy it is. But you gotta go back to this diagram and everything that is happening. But the whole point of this is to make it simple for the user, which is what matters, right? And that is trustless, which is another point that I wanted to bring with the multi-chain hack happening at the beginning, right? So this is basically how it looks. You go to the Moonbeam dApp, you go into the Moonbeam bridge if you're in Moonriver, and you say, okay, I want to move movers from this address to this address to Moonbeam. You say, I want to move 0.1 mover. Everything, the fees and everything are calculated already by using the XCM dry runs. You sign a transaction, and the transaction takes a little bit, right? Because XCM happens under the same consensus algorithm. In this sense, you have to wait for the relay chain block to be finalized, the relayer to pick it up, inject it on the destination chain. So it's a bit slower. It takes like a minute or two, usually more than a minute. And then you see the transaction that the person signed on the Moonriver side. It is basically sending an XCM message. And on the Moonbeam side, you have a Etherscan transaction that is moving an ERC20 token as you would, with any other place. But the user experience is very native to any bridge out there. So it's not, the complexity is all abstracted. And it's like you're using any famous bridge out there, or you're using Snowbridge. At the end of the day, there's no complexity. And like I said, the only attack vector is censorship, right? If the relayer is being run by an infrastructure provider to the Moonbeam Foundation, and if they one day want to shut it down, then anyone else can run a relayer and point it and start moving messages. So it makes it very, very seamless. So to wrap up, I wanted to sort of highlight the bridge itself, right? So it is Polkadot SDK based. It was not developed by us. It was using technology that Parity already developed and modules. It is 100% decentralized and trustless. I don't know if we want to call the censorship resistant bit not fully decentralized, so maybe, I don't know, 99% decentralized, but there's a way around the censorship problem. And it's relaying, relay chain stuff between consensus. Seamless UX, as you saw in the video, the flows are embedded and all the complexities are abstracted, and they're actually part of the Moonbeam XCM SDK. So it's completely integrated into the SDK. And one really cool thing that we're enabling soon is MRL. So if you're not familiar with what MRL is, it's Moonbeam Routed Liquidity. It's a system that Moonbeam developed to move liquidity from, for example, Ethereum to a parachain within the Polkadot ecosystem in one click. Right, so if you have ETH, if you have USDC, USDT, you can move it to hydration, for example. Signing one signature, you don't have to do the typical hop. It's like, okay, I signed it on Ethereum. Let me go to Moonbeam. Okay, now I'm going to move it to hydration. It's only one click, in and out. And with the Moonriver Trustless Bridge, we can actually enable that flow as well, which is crazy because you're moving from Ethereum to the Polkadot consensus mechanism, and then from the Polkadot consensus, you're moving it to the Kusama consensus. But it all happens with a single signature, no complex hopping or anything, right? And this is something that the Moonbeam team will release shortly in the next runtime upgrade. So that would allow the Moonriver ecosystem to get access to Ethereum liquidity and so on in a trustless system, which is really nice. So yeah, I think that's all I had today. So you can find the QR code for the slides, or they're in the URL down there. The information about Moonbeam is on the slide as well. And I'm happy to answer any questions if you have any. Thank you.
Maybe one.
Right.
Yeah, let me grab a mic for you.
Only one question.
Sure. But you will be around, right?
Yeah, I'll be around.
You'll be around, so definitely go hang out with Alberto. Go ahead, we've got some time.
Hi.
Thanks, Alberto. Nice talk.
That side.
This one. Hi. Nice talk, Alberto. Thank you. About the fact that this is not censorship resistant, can you not just permissionlessly allow that people spin up their own relayers? Because if there are multiple relayers, they cannot have conflicting information. They can just convey the right information. There's just one truth there, namely the blocks, and you cannot just fake this.
Yeah.
And then it's not.
Yeah, no worries. Yeah, so I understand. So
yep.
I think it's an issue, right? Like an issue that, for example, it is not easy for a person to run a relayer, right? And truth be told, right now we're not making it easy because we don't have documentation on how to do it. But right now, the problem that we were trying to solve is how to connect them, right? How to connect Moonbeam to Moonriver. But I think down the road, if I understood the question correctly, is that we will have documentation for people to run their own relayer, because that will make it, at least in a transparent way, censorship resistant.
Exactly.
Right now, you could say that it's not, because yeah, you can run your own relayer, Thorsten, but then you have to go figure it out, and it's just a lot of headaches, right?
Yeah, understood. Okay.
But right now, the first step was get it running, get the flows in and out, get MRL. For us, well, not for us, for the Moonbeam team, it is a higher priority to enable MRL because that will bring Ethereum liquidity to Moonriver. But then the censorship problem can be easily solved by just like posting a tutorial on how to run the relayer. So yeah, but it's a great point. It's a great point. Thank you.
Thank you for that. Let's get